All right, welcome back. Now that we've downloaded and installed DexDesign, we're now ready to prepare a file. So if you haven't already, run through the master protocol that's described in step 1 of the JCP protocol in order to generate a D-peptide and complex with an L protein. Once you've done this, you can obtain it and save it to your desktop. So as you can see, I have it here. I've saved it here as match4.pdb. So let's navigate to where we've set up DexDesign, which I have it in downloads. And we're again going to open up that interface with setup design. Once you have this interface, we want to import that complex. So we're going to click File, Import PDB. So here I have my match4.pdb appears. I'm going to click that file, I'm going to click Open. And as you can see, a new menu will appear, which shows that complex visualized. So we have a number of options. So let's begin to prepare this file so we can begin running the K-star algorithm and do some designs. So we're going to click Prepare, and we're going to go down this menu all the way through protonation. So first we're going to look at Filter. If we click this, we see two new items pop up. We have chain Y, which is the protein, as you can see is highlighted in the visualization on the right. And then we have chain A, which is our D-peptide right here in front. Now, we want to include both of these chains, but if you had a complex that had other chains that you did not want in your design, you could unclick them and it will disappear. So you can see, unclick this protein, it will disappear. But we want to keep both of these components in the design for now, so we're just going to close this menu. From there, we're going to go to chirality. So this is a D-peptide, so we're going to check yes, that this chain A, the D-peptide, is a D. We're then going to go to duplicated atoms. So we see here, chain A has no duplicated atoms detected, chain Y, so we're going to close this menu. Next, we're going to go down past duplicate atoms to missing atoms, and we're going to click Add Missing Atoms Automatically. On chain A, which is that peptide, the D-peptide, we're detected a missing oxygen, and that's not been corrected. So we can close this menu, hit Prepare again. We're going to click Bonds, clear all bonds if there's any in the PDB file, and then add bonds automatically. Watch this visualization on the right when I click this button. And now we have connectivity in our complex. I'm going to close this menu. Lastly, we're going to hit Prepare, Protonation. We're always recommending stripping all hydrogens that might be in the PDB, so clear all hydrogens, and then add hydrogens automatically, and this structure will now be protonated. We're then going to save this file. So first we're going to hit File, Export PDB, and I'm just going to save it to the desktop for now. So I'll call this match4 prepared. And then lastly, what you're going to do is you're going to click Save OMOL. That stands for OSPREY molecule. This is a certain type of file format that will allow us to customize our conformation and sequence space, which we'll get to in a later video. So we click Save OMOL. I'll save this as match4. So I'm going to close the interface. You can click File, Close, Exit. And now I have match4, which is the original input PDB. I have a match.omol, which I'm actually going to move to be match4.omol. And also my prepared PDB. And this is the PDB with connectivity information, protonation, and also that corrected oxygen. I'm going to make a directory called DexDesign. And I'm just going to move all of these into that directory. After that, it's now time to move on to the minimum flexible set.